Good morning, everybody. You should see my screen now. I will, So I will present you a short overview about the Austrian case study. The title of my presentation today is Introducing an EPC after completion of the building works, the reasons behind and preliminary lessons learned from our case study in the region of Salzburg. What is the content of my presentation today? I will introduce you on the background on the Austrian framework conditions, and then present you a few preliminary results from our work, and of course give a short outlook on what will still come. So Austria is one of the 9 member states involved in QUALICHECK and doing a case study on a specific topic, and we work on the region of Salzburg. You see it here, so it is one of the 9 regions in charge of transposing and implementing the EPPD in Austria. How is the EPPD transposition and implementation organized in Austria? We have 9 regions. They are all represented in the OIB, the Austrian Institute of Construction Engineering. This institute develops a guideline. All the provinces are contributing, and this guideline is then the basis for the revision of the building legislation in the provinces. And I will not go into detail now, but what is important for our subject in QUALICHECK is that the building laws of the Austrian provinces reference this guideline, and the guideline references Austrian standards, thus becoming part of the legislation. And what you see here is just let's say, a list of relevant standards. I will also not go into detail here. Just what is important for our topic is that these standards contain default values, which we use as input data in EPC calculation software. They also contain information about procedures. So this is why this is important for our work here. So this slide shows the background of the Austrian case study. In fact, we have legal requirements, and this legal requirement is to produce an EPC and show that energy performance minimum requirement is met. There are several measures how to check compliance, like automatic checks in calculation programs and during upload in the EPC database. There is enforcement, like tied to building permits and financial incentives. And then we have a big, let's say, area of quality assurance methods at different levels. And these quality assurance methods can take place during the design phase and the completion phase. Usually in Austria we have only one type of EPC, the so-called design EPC, which is issued at a very early stage of design and necessary to achieve the building permit. In the region of Salzburg, there is also a second type of EPC issued after completion and necessary to achieve a specific type of financial incentive. And in our case study, we analyze the quality of the preliminary EPC and the final EPC in the region of Salzburg to see what are reasons at the very early stage during building design and EPC calculation for deviations due to a range of interpretation concerning input data. Do we have a deviation from plan, for instance, because different products have been chosen than actually planned? And then, of course, there is another let's say, important aspect for quality of EPCs and also for the building as such, which means how is it with the quality of the works? Are there mistakes during construction? So in fact, the expectation is that the final EPC contains was updated concerning changes in building design, and also reflects the quality of the works. So what are the objectives and the scope of the Austrian QUALICHECK study? The objective is to analyze the range of deviation of EPC energy performance indicators depending on the quality of input data and the type of EPC. So whether we see the design EPC or the final EPC. Then it is the objective to analyze the cause of deviation and develop recommendations how to improve, and especially to develop recommendations for the administration in Salzburg, how this can be linked with compliance and enforcement. What is our scope? We analyze 26 multi-unit new residential buildings in rural and urban areas. They are well documented, and the surface area is approximately 30,000 square meters. In our analysis, we focus on 4 scientific areas: transmission characteristics, ventilations and air tightness, sustainable summer comfort technologies, and renewables in multi-energy systems. How do we proceed? So we put a lot of effort in data collection. We collected the design EPC, the completion EPC, but in addition, specific building information like site foreman's plans. And then we did a comparison of the design EPC with the original completion EPC, and we did a complete recalculation of the completion EPC based on the collected building information. The analysis is then continued in site visits of selected buildings, inspection and check of crucial parameters. All this information is used to also do a detailed investigation of specific questions, for instance, solar thermal systems and experts interviews. And the study ends with developing of recommendations for the administration of Salzburg region, how to improve the quality and achieve better compliance. In this regard, the project team or the composition of the project team is important. We cooperate with the administration, with the region of Salzburg, with the public body who is in charge of implementing the EPBD and also runs the regional EPC database. We cooperate with the building owners and with the EPC calculation software company because the findings regarding input data and default values will be very important for them. This is part of the summaries of. This is part of the result, which is already available. What you see here is here are our 26 buildings. The gray column shows you the original completion EPC, and what you see here is an energy indicator. It's the heating energy demand. It's an indicator for the energy performance of the building envelope. The orange column is the recalculated completion EPC. The line here is the deviation, and the red mark here shows the buildings which I will go a little bit into detail. So we have quite some deviation here, and the reason for the deviation in this case is that the most important reasons are that part of the conditioned areas are not taken into account in the original calculation, and that in the original calculation they only took into account one type of wall construction instead of different types, and of course this has an impact on the U values. These are quite typical mistakes. The next building, it's building 10. There is not so much difference between the original indicator and the recalculated one, but in this case, mistakes balance each other, which means there are quite some deviations, but in the end, the result does not deviate so much. Again, part of the conditioned area was not considered, and indoor wall was defined as outdoor wall in the original EPC. And then we have another example here where the recalculated indicator is just a little bit worse than the original, and there were differences in the window area and no zoning between residential part and commercial part. So these were some exemplary findings from the recalculation of EPCs, and to show you an example how we go about the detailed analysis of specific subjects, and in our case it's thermal bridges, shading, and solar thermal systems. Regarding thermal bridges, we do different calculations. We calculate with default values according to standard. We calculate with detailed reference values, and we do a simulation to see how the input data impact on the calculation result. And in fact, detailed calculations result in better indicators. Our indicator heating energy demand is improved quite substantially. We do a similar analysis regarding thermal solar systems, also calculate with different calculation programs and different type of input data to analyze the difference and the reasons for the difference. So what are the preliminary results? Just to summarize, we have some findings regarding input data, and in fact, mistakes or deviations are due to definitions, definitions which need to be improved to be unambiguous. So the range of interpretation has to be reduced. So this is one of the problems we have in practice. We need a revision of default data, and we need a solution how to deal with heating systems, because it's difficult to deal with them at the moment. The analysis regarding EPC update shows that there are quite many design changes, and therefore the design EPC must be updated to have a final EPC, including design changes. However, it must be ensured that the EPC is actually updated based on the final design documents. So our analysis showed that the original completion EPC often does not differ so much from the design EPC. How do we proceed? We will select, or we have already selected some crucial buildings, and we check them during site visits, and this should be finalized this week. The detailed analysis should be finalized by September, and the recommendations for the administration should also be finalized by September. So this was a short overview about the Austrian case study within QUALICHECK, and I will now stop sharing my desk and hand over to the next presenter.